Hello everyone. The filter dust collector uses porous filter media, trapping dust particles in gas solid fluid. A high-efficiency dust removal equipment that has been separated, divided into bag-type dust collectors. There are two types of dust collectors: granular layer dust collector. Today's main focus is on bag filters. Mainly explained to everyone from these 5 aspects. Dust removal mechanism of bag filter. Bag filter. It is a surface filter using fabric as the filter material, mainly including 5 functions: interception, collision, static electricity, diffusion, and sedimentation. Its advantages are simple structure, reliable performance, high dust removal efficiency, and no influence of specific resistance. Stable operation, strong adaptability, and high flow rate. Easy to recycle. There is no problem with sludge recovery. High removal rate for micron and submicron particles. Over 99%. Trappable dry powder, especially for ions with high contrast resistance. Much more efficient than electric dust removal. Disadvantages: limited temperature and corrosion resistance. Temperature less than 300 degrees Celsius. Not suitable for dust with strong adhesion and moisture absorption. Structure and classification of common bag dust removal. 1. According to the classification of dust removal methods, there are mechanical vibrations. Utilizing mechanical devices such as electric, electromagnetic, or pneumatic devices. Bag filter for cleaning dust by vibrating filter bag. Intermittent cleaning. Its pressure loss is 800 to 1200 pascals. The filtering speed is 1 to 2 meters per minute. Features: simple structure, high cleaning strength but uneven, fast wear and tear, frequent maintenance. This is a picture of a mechanical shock bag filter. 2. Counterblow type. Using a valve to switch the airflow under the action of reverse blowing airflow. Make the filter bag shrink or bulge and shake. Bag filter for dust removal. According to the difference in reverse blowing airflow, it can also be divided into chamber back blowing and nozzle back blowing categories. Support ring needs to be installed. The loss is between 1000 to 1500 par. Filter 0.5 to 1.2 meters per minute. Simple structure. Good cleaning effect. Low mechanical wear of filter bags. Applicable to glass fiber filter bag with low dust viscosity and the weakest strength. Divided into chamber back blowing type and nozzle back blowing type. This is a schematic diagram of the chamber reverse blowing type. Nozzle reverse blowing type. It is provided with a high pressure fan or compressor to provide reverse blowing airflow. Low back through a moving nozzle. Bag filter for deforming and shaking filter bag and penetrating filter material to remove dust. This is the schematic diagram of the rotary reverse blowing flat bag dust collector. ZC type rotary reverse blowing flat bag dust collector. 3. Pulse injection type uses compressed air as the cleaning power. Utilizing pulse blowing mechanism. Release compressed air in an instant. High-speed injection into filter bag. Make the filter bag bulge sharply. Bag type dust collector that relies on impact vibration and reverse airflow to clean dust. Speed 2 to 4 meters per minute. It has many advantages, but the cost is high. This is the structural schematic diagram of a pulse jet bag filter. Flowback at 4 to 7 atmospheres. Compressed air pulse generates shock waves. Make the filter bag vibrate. Mechanical ash cleaning. General internal filtration type. And pulse cleaning adopts an external filter type. 1 pulse for 0.1 to 0.2 seconds. Pulse cycle of 60 seconds for all filter belts to complete ash cleaning. Take an appropriate amount of air and a suitable pulse time. Excessive dust removal is not possible. High filtration load and light wear of filter bag. Safe and reliable. Wider application. This is a pulse jet bag filter. 2. Classified according to the form of flat bags. Flat bags are generally of external filtration type. The interior must be supported by a skeleton, complex structure, high production requirements, and it's not easy to clean the dust. But the filtration area is 20% to 40% larger than that of round bags. Relatively compact, circular bags are widely used. Diameter 120 to 300 mm, maximum not exceeding 600 mm. Bag length 2 to 12 meters. Well stressed, simple support framework and connecting tube. Easy to achieve good cleaning effect, and it is not easily blocked. 3. According to the filtration mode, it is divided into internal filtration type, mechanical vibration airflow reverse blowing internal ash cleaning method. Generally, internal filter type is used. The external filter type must have a skeleton inside. The filter bag is easily damaged. Difficulty in maintenance. Pulse injection and high pressure backflow multipurpose external filter type. Factors affecting the dust removal efficiency of bag filters. 1. Filtering wind speed. Filtering wind speed of bag filter. It refers to the average speed of gas passing through the filter cloth. In engineering, refers to unit time, the flow rate of gas contained in the filter cloth per unit area. This formula can be used for calculation. 2. Pressure loss. The pressure loss of bag filter is one of the important technical and economic indicators. It not only determines the energy consumption of the dust collector, it also determines the dust removal efficiency of the device and the time interval for dust removal. Pressure loss of bag filter. It is caused by the structural loss PC of the dust collector, pressure loss PF, and pressure loss P decomposition of the filter layer. This is the pressure loss of the filter layer, which can be calculated using this formula. 3. Properties of filter material. According to processing methods, it can be divided into woven filter materials, non-woven filter materials, and membrane-covered filter materials. According to the material used, there are natural fiber filter materials, synthetic fiber filter material, composite fiber filter material. According to the weaving method, it can be divided into plain weave weaving, twill weaving, and satin weaving. The filter material is also the core part of it. Its cost accounts for 10% to 15% of the entire bag filter. Ideal filter fabric properties: high dust collection efficiency and easy cleaning, low resistance, wear resistance, corrosion resistance, temperature resistance, low cost and long lifespan. 4. Ash cleaning method and cycle. Cleaning method of bag filter. It can be divided into mechanical vibration dust cleaning, reverse blow cleaning, pulse jet cleaning, and composite cleaning. The selection of bag filters is generally based on when the water content is low and there is no acidity. Select based on the temperature of the dusty gas. When the moisture content is high. When the dust concentration is high. Waterproof and oil-resistant filter materials should be selected, or membrane-covered filter material. When the dusty gas contains acid and alkali. When the gas temperature is below 190 C. Frequently using Litong needle felt if the gas temperature is below 240 C. When the requirements for acid and alkaline resistance are not too high. P84 needle felt can be selected. When the dusty gas is flammable and explosive, choose anti-static polyester needle felt. When the dusty gas contains a certain amount of moisture. When it is a flammable and explosive gas, again select waterproof, oil-proof, and anti-static polyester needle felt. There are several main design principles for bag filters. Mainly filter dust of about 1 micron. When the concentration is greater than 15 grams per cubic meter, preferably it would be pre-treatment. High concentration or fine dust selection at low speed. Low concentration high speed selection under consideration of height limitation, air intake, limited installation area considering flat bags, high temperature, cool down, choose temperature resistance considering high humidity, consider air loop backflushing and insulation. Purification of harmful gases should be considered. Selection of bag filter. 1. Determination of main performance. Calculation of filtration area. According to the size of gas processing capacity, choose the appropriate filtration area. If the area is too large, so the equipment investment is high. If the area is too small, then the filtration resistance is high. High operating costs. Short service life of filter cloth. Filter area of dust collector. It can be calculated according to the following equation. 2. Selection of filtering speed. Filtered wind speed refers to the unit time, the amount of gas passing through the filter cloth per unit area. Reference can be made based on the type of filter material and ash cleaning method. Make a selection. Filter fraction selection range. Polyester filter material, typically 0.6 to 1.0 meters per minute. Glass fiber filter material is generally 0.4 to 0.5 meters per minute. 3. Determination of the number of filter bags. It can be calculated according to the following equation. The diameter of the filter bag is determined by the specifications of the filter cloth. Length L of filter bag, not directly related to efficiency and pressure loss, usually 3 to 5 meters. Filter bag diameter is generally 100 to 600 millimeters, commonly used 200 to 300 millimeters. 4. Selection of pressure loss. When using primary dust removal, general pressure loss at 980 to 1470 pascals. When using secondary dust removal, general pressure loss at 490 to 784 pascals. Selection of filtering materials based on the properties of the gas and the nature of the dust for selection. 6. Selection of filter bags for ash removal methods. You can refer to the ruler table. That's the end of this lesson. Thank you all.